Hello students, we are doing volume of different solids, and today we're doing volume of prisms and cylinders. So, new shape, what's a prism? These are prisms. What kind of prisms are these? This one is a rectangular prism. What did we talk about recently on this one? What kind of prism is this? This is a triangular prism. Even though the base is, even though it's sitting on this rectangle, it's not the base. Do you guys remember this one? This was the pentagonal prism. What's this one called? This could be called a square prism, but we call it a cube. It's also a rectangular prism. This one is also a triangular prism. So what makes something a prism? A prism is a polyhedron. That means it's a solid three-dimensional object and all the faces are polygons. That's a polyhedron with two congruent and parallel bases. So prism has to have two of the faces both congruent and parallel. In a rectangular prism, any of the two across from each other could be bases because there are three sets of congruent and parallel faces. But in this one, the bases are the triangles. So prisms have two bases. This triangle is a base, and the other base is the same size and shape triangle that's in the back here. So those are your two bases. They're the two triangles. The bases of the prism are parallel and congruent. So where are the bases here? This is the base. I'm just going to do it in the middle of the face, and this is the base. Bases. Even if it's sitting on a different side, these are the bases of the prism. Here and here are the bases. Okay, one other thing that's important to know about pyramids, one other vocabulary word is the height. What is the height of the prism? For this one, it's pretty straightforward. How high do you think this is? Well, I think this is how high it is. From here, the distance from here to here, I would call that the height. But this one is tricky. This is not the height of the prism. The height of the prism is this. This is the height of the prism. So the height of the prism, you gotta be careful with. If it's a rectangle, it doesn't matter. A rectangular prism, it doesn't matter quite so much. But if it's a triangular prism or a pentagonal prism, you need to be really careful. The height of the prism is what? How do you know that that was the height? Is the distance between the bases. The height of the prism is the distance between the bases. That's really important, which means that where is the height of this prism? Is it this? It's this. This is the height of the prism. This is the height of the prism. Now, hold on just a second. The triangle is the base, right? I'm going to draw this right triangle. I'm going to pretend like I took it and this is this shape here. This triangle, this base, also has a height and a base. Okay, this little height is not the height of the prism. It's the height of the base, which sometimes you need. So you got to be careful. What's going on with this one? Is this a prism? Is it a polyhedron? Like, are all the sides, this isn't letting me, are all the sides congruent, and are all the sides polygons? Yes. Does it have two congruent parallel faces? Yep. So this is, but it's weird, right? It's kind of tilted. This is called an oblique rectangular prism. This is called an oblique rectangular prism. Well, that's kind of an interesting idea. I wonder where the height of that one is. We'll find out. All right, so we can name shapes, we can talk about, we can label their bases, we can look for their height. But another thing we can do with three-dimensional figures is we can calculate the volume. So I'm going to assume these are beautiful little cubes floating and flying around here. And I want to investigate with you, what is the volume of this cube? The volume of this cube is, the volume of the cube is 1 cube. The volume of this cube is 1 cube. What's the volume of this cube? Kind of a trick question. It's 1 cube. The volume of this cube is 1 cube. How many 1 cubes are in there? Well, we could count it up. Some people were having some problems visualizing this in class, so I pulled this up. Let me see if I can get it. It's having trouble loading. There we go. Okay. So this is kind of a fun thing to play with to help you visualize volume. Can I get it? I like it like that. Okay, so I'm going to set these all to 1. This is 1 cube kind of in the corner here. I can make it more see-through or more filled in. And I can build bigger cubes. So I could go 2 out that way, 2 out that way, and 2 layers. How many cubes are there in that 2 by 2 by 2? Well, I could count them. There's 4 in that layer, and then another 4 on top. So the volume of this cube is going to be 4. I mean, the volume of this cube is 8 cubes. Wow. The volume is 8 cubes. 8 small cubes. 8 small cubes. You could say the volume's 1 big cube, or you could say it's 8 small cubes. Okay, how about this volume? This volume is either 1 big cube or how many small cubes? Well, let's build that one. Okay, we now have, I'm gonna take it down to the first layer. I'm gonna have 3 by 3. So how many in that layer? 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 9 in that layer, and then if I want to make it a cube, it has to be, all these numbers have to match. So what's a 3 by 3 by 3? Well, let's see, we had 9 in the first layer, and another 9 on top of that, and another 9 on top of that. So how much is that? That's 27 cubes. So the volume of this cube is 27 small cubes, or 1 big cube. If you want to be super lazy and I give you a picture of a cube and I say, what's the volume? You could say, hey, it's 1 giant cube. Okay, again, the volume of this cube is 1 cube, 1 big cube, or you could say the volume, and we usually use a capital V for volume. And this is going to be 4 by 4 by 4, which is how much? Let's see if this one can do it. I don't even know. Can I go to 4? Yeah, I can. 4 by 4 by 4. That is a lot of cubes. 16 times 4 is 64, I think. 64 little cubes and one big cube. So volume is the number of cubes that fit inside a figure. Volume is the number of cubes. 16 times 4. The volume of prisms is simply the product of the area of the base times the height of the prism. And we were kind of playing with that idea already. So the way that you would read this is the big B stands for base area. Base area. I'm going to write that. The capital B in the formula, the capital B stands for base area of the base of the prism. The base area of the base of the prism. So this prism, we're going to call this the base. And if you found this area and then you multiplied it by how many layers you had by the height, that's going to give you how many cubes can fit inside of this beautiful little. We want to start filling it with cubes, right? We want to see how many cubes would fit in the bottom, and then how many rows do we have? How many layers? Now let's do a math problem. So it says find the volume, show work neatly, write the formula, substitute values and units. So I'm going to do volume of a prism is equal to the base area times the height. And the volume of this prism is going to be, the base area for this one is going to be, which one do we want to call the base? I'm going to do this as the base. So it's 12 along here, and how much along here? What's this base? This is 9, isn't it? Yeah. Because I'm going to call this the base down here. All of the base of the base. Okay, and we're calling this the height, the distance between the bases. So I'm going to do it this way. I'm going to put the height in first. The height is 14 inches. It says include units in my work. I'm going to, you don't have to do this, but I'm going to say that these together are the base area. So I'm going to do it 12 inches times a 9 inch. And maybe when you were little, you learned length times width times height. It's the same thing. It's just a slightly different way to think about it. So what am I going to do? I'm going to multiply those numbers together. The base area is going to be the 12 inches times the 9 inches. And what is inches times inches times inches? So I'm going to do it this way. This is 108 inches squared for the base. And then we have another 14 inches. And you can see, hopefully you can see, that if you multiply inches by inches by inches, that's going to give you inch cubes. So we're finding out how many inch cubes fit inside of this figure. And this is a really giant number. 1,512 little teeny tiny inch cubes would fit inside of that random rectangular prism we had right there. Okay, interesting. I'm going to skip this one. It's interesting. A lot of real world things do involve volume, and I actually owned some neon tetras for a while. And I'm going to be really weird and stop my virtual background. Oops. And I didn't mean to stop my video. And I'm going to show you my fish tank. Ooh, look. Volume is interesting and important, and might need to think about it if you have a fish tank. I'm going to keep that background off. Okay, let's do another one. So this is a prism. I'm going to do volume of the prism formula is the capital B base area times the height of the prism. Again, the height of this prism is what? It's 14 inches. That's the distance between the triangles. And I'm going to do this one a little different. I'm going to go and figure out the base area over here. Okay, so I'm going to go do the calculation for the base area off to the side. You can do it within the same formula, but but sometimes it's easier to think about it off to the side. Okay, so what is the base of this picture? The base of this picture is a right triangle, and the right triangle has a little height of 5 inches and a little base of 12 inches. All right, so who remembers the area? I'll call it base area of a triangle. What's the area of a triangle? It's half the base times the height. Well, this is the little base, right? It's not the base of the prism, but it is the base of the triangle. And this is the little height. So we're going to do half of 12 inches times 5 inches. Anyone know what that is? Half of 12 is 6. So 6 inches times 5 inches is 30 inches what? Squared. Because we're doing area, we're counting the number of squares. So now that I found the base area, I'm going to substitute that into here. And if I am multiplying inches squared by inches, what shape am I going to get? Inches times inches times inches is inches cubed. All right, and I'm going to do 30 times 14. And that is 420. 420 cubes would fit inside of there. You have 30-inch cubes along the bottom, and then you have a stack of 14 of them. Ooh, what shape is that? We haven't looked at one of those before. I'm going to try to find the volume of the prism. And the volume of the prism is the base area, and then you multiply it by how many layers, the height. Anyone know what the height is on this one? It's not 8. Do we know the name of this shape? I like this one. Well, what shape is this? There's 2 of those, right? Those are parallel and congruent. Those are trapezoids. So the name of this shape is a trapezoidal prism. Sounds kind of cool. Hello, trapezoidal prism. Nice to meet you. All right, so what is the base and what is the height? Good. The height is the distance between the bases, and the bases are the trapezoids. Okay, so I'm going to do the base area calculation over here, and I'm just going to draw my trapezoid away from the prism. Just kind of keep it a little organized. Haven't done these in a while. Haven't done area formulas in a while, so. Okay, so I'm redrawing the picture, the base separate, because if I can find the area of this, then I'm just going to multiply it by the height of the prism, which is 15 centimeters. It's the height of the prism. Okay, so what's the formula for the area of a trapezoid? Does anyone remember? Base area of a trapezoid. That's a tough one, huh? Okay, you might have to look it up. It is half base 1 plus base 2 times height. And do we know the height of the base? Yeah, the height of the base, we look for the right angle. That's how tall the base is. That's the, you know, the baby base height. Okay. And what are these B1 and B2? What are those for? Well, a trapezoid has one pair of parallel sides and those sides are the bases. So this base is 10. Uh-oh, do we know how long this is? We can kind of go back to this. Oh, look, it's 6. Okay, so I can bring in my 6 centimeters over here. So it's half of, oh, I didn't leave enough room for myself. Okay, so the formula for area of a trapezoid is half the base 1 plus base 2 times the height. And base 1, I'm going to say is 10 centimeters. And base 2, I'm going to say is 6 centimeters. And the height of the trapezoid is 8 centimeters. All right, wait a minute. Let's focus on our units here. What's 10 centimeters plus 6 centimeters? If I gave someone 10 centimeters of string and I gave someone else 6 centimeters of string and I said, put them together, what do you have? You have 16 centimeters of string. You magically, if I give you a piece of string, do you magically have squares? Centimeters plus centimeters is still centimeters. But in the next step, we're going to multiply. So I'm going to do half of 16, which is 8 centimeters. And what is 8 centimeters times 8 centimeters? I did not plan my space very well. Okay, this is 64 centimeters squared. That's not the answer, but that is, I need to do something with that. So I found the area of the base. The area of the base is 64 centimeters. 64 centimeters squares would fit in this amount. Some of them would be cut off. Okay, how many layers do I have? I have 15 layers of those. So I'm going to take my 64 centimeters squared, area of the base, the number of squares that fit in the base, and I'm going to multiply it by 64. I mean 15, so 64 times 15 is 960. 960 what? 960 little teeny tiny cubes would fit inside of that prism. Some might have to be cut. All right, that is how those work. What is going on here? Well, you guys are so lucky because I am in the middle of a project of burning CDs for my family. So what I have here is a set of jewel cases with CDs in them. And what I can do here is I can kind of offset them, right? If I tilt them like that, do I still have the same amount of mass? Is it easier to find the volume of a stack or if it's all like cattywampus? Ooh, interesting. So let me show you on the website also. These don't tend to look very well. So there was an Italian mathematician, his name was Cavalieri, and I think he was a monk. I did put a Wikipedia article up for him. He's kind of interesting guy. And he was thinking about how it's harder to find the, or how are these, two stacks of things related? And could I just straighten it out and just use that? Let's see. It's really trying to load here. There we go. Here's Cavalieri's principle. So he said that both of these stacks have the same volume. And you can show that by sliding over each slice of the wiggly one. Okay. And you can see that exactly, as long as they're the same height and they have the same base area, it doesn't matter if it looks all wiggly. Okay, another way to say that, another way to show that is that you could straighten out the stack. So you can either like wiggle the stack around like I did with my CD cases, and then you can see that they all fit perfectly if it was straightened out. And the other way to see it is this way. We were talking about cross sections the other day. So all of the cross sections are congruent here. All the cross sections are congruent. So even if it's wiggly, they still have exactly the same right triangle cross sections. This is called Cavallari's principle. He says, if two three-dimensional figures have the same height, so they're all, the distance between the bases is all the same height, they have the same cross-sectional area at every level, then they have the same volume. So if all of these base areas are equal to each other, even if the shapes are all different, they're all going to have the same volume. Kind of interesting. So how do you do this one? Well, you don't freak out that it's oblique. All you do is you say, okay, it's an oblique prism, but it's still a prism. And the volume of a prism is the base area times the height. So the volume of this prism is, well, the base is a rectangle. So how many squares fit in this base? It's a 5 by 6, right? I could really go in here really carefully. I could draw 5 by 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I could count up all the squares and I could see that there's 30 centimeters squares fit in the bottom. And how many stacks of those do I have? I have 4 centimeter stacks. So the volume of this prism, even though it's oblique, is 120 centimeters cubed. Now, the only thing you have to be careful about with these is not to use this. If they give it to you, they're trying to trick you. Don't use the slant height. Every once in a while, they'll put a number here, like maybe it's going to be longer than 4 because it's slanted, right? Maybe it's like 4.3. If they gave that to you and were trying to be really mean, maybe because you needed to find the surface area, make sure you don't use the slant height for volume. You need to use the height of the prism, which is the distance between the two bases. That's an interesting question. Do these have the same surface area? They have the equal volumes. I don't know if they have the same surface area. Okay. Ooh, new shape. What are these? Cylinders. What's your favorite kind of soup? So cylinders are the same as prisms, except what? Cylinders are like prisms, but with circles. As the congruent and parallel bases. And the volume formula is exactly the same. But it is kind of weird to think about putting cubes inside of cylinders. Mostly we put liquids or, you know, like squishy stuff instead. Turn the world back on. Okay. So here's the formula. The base area is the area of a circle because the base of a cylinder is a circle. So it's pi r squared h. Let's practice 2 of them. So you're going to do the volume of a cylinder. You have a choice. You could start by writing base area times height, or if you want to start the volume of a cylinder, you want to start with pi r squared h, that's fine. You should always write the formula, at least write one of these 2. Probably this one is better. And what is the height of this cylinder? How far apart are the two circles? It's kind of interesting because for volume of a cylinder, you only need two things given. For prisms, you need usually 3 or more pieces of information. But with cylinders, you only need the radius and the height. You need to know the size of the circle and how many stacks. So for this one, and I do want you to include units, it's 2 meters squared, and the height is 5 meters because that's how far apart the bases are. So it's kind of weird. This is the height. The height is not 4. The diameter is 4 meters, but the height is not. And then you finish it. Do you guys know what 2 meters times 2 meters is? 2 meters times 2 meters is 4 meters squared times 5 meters. And when you're leaving pi in your answer, which as a mathematician, which you guys are now because you're students of mathematics, you want to include pi in your answer now that you're doing more higher math stuff. So we're going to put the regular rational number in front. Then we're going to put the irrational number, which is pi. And then at the back, we're going to put our units. So write your answer in this order. You're going to put the number, then irrational number, like pi or square roots. And then at the back, then you'll put your units. That's the order we list our answer. So it would be weird if you wrote pi 20 meters cubed. This is the order we want. If it's a real life situation, if you're actually in a business where you need to know the volume of your cylinders or vats of whatever you're creating, you can abbreviate. Really good idea for this is to use a calculator, and then we're going to put our approximate answer. So depending on the accuracy that you need in your business, it will depend on how many decimals you go out. Okay, but this is around 62.8 meters cubed. All right, what if it's oblique? You don't freak out, you just do it. Could you find the slant height here? That would be a fun extra little problem. Probably have to use right triangles, I'm not sure. Okay, this is going to be the perpendicular distance between the bases. So it's still a cylinder. I'm still going to use the volume of a cylinder. Cavallari says I don't have to stress if it's oblique. I'm still doing base area times height. So I'm still going to do, you know what? I'm going to be lazy. I'm going to do pi r squared h. Pi r squared h. Okay, so the volume of this cylinder is pi times, oh, what did they give us? They almost tricked me. They gave us the diameter. What do I need? I need the radius. Okay, so you have to do, sometimes you have to do a little extra work. The radius is 4 inches because it's half the diameter. So we have 4 inches squared times the height of the prism, or in this case, cylinder, is 11 inches. And to finish this up, we would do 4 inches times 4 inches, which is 16 squares, 16 inches squared times 11 inches. You can see it, inches times inches times inches is inches cubed. It's not good if we don't have inches cubed. I'm going to do 16 times 11, which is 176 pi. Don't forget about pi, inches cubed. That's a beautiful answer for a math class. And if you're doing anything real life, you would want to multiply in with pi. And you would get around 553, I'm going to round it, cubic inches of stuff. of volume, of juice, of whatever is in that lovely oblique cylinder. All right. Good job, you guys. Keep learning. Be good. Work hard. See you next time. Bye.